Today we're going to be using linear models. So let's first do some review. Remember, the domain is the possible input values, our x values of a function, and our range is the acceptable output values, our y values of a function. Remember, we spent the last few days reviewing slope, intercept, form, point, slope, and standard, so they're here as well if we need to use them. So let's take a look at our first example. A balloon takes off from a height of 20 feet above sea level. It rises 40 feet per minute. Make a table of values and create a scatter plot of the situation. So if we take a look, we need our x and y. So let's say we label our y, our feet, the height, and x will be our minutes, the time. So we know that before the balloon actually takes off, so after 0 minutes, the balloon is 20 feet in the air. Then after 1 minute, the balloon has risen 40 feet, so now we're at 60 feet in the air. So after 2 minutes, we'd be at 100. 3 would be at 140. And at 4, we would be at 180 feet. So every minute, we are increasing by 40 feet. So let's make a scatter plot. So if our x is our minutes, I'm going to go up by ones, 1, 2, 3. And then y's are our feet. I'm going to go up by 10, so 10, 20, 30, 40, 50, 60. Alright, so we have our graph labeled. So now let's make our first part. We have 0, 20, 1, 60, 2, 100, 3, 140, and 4, 180. Alright, now let's look at the next question. It says to write an equation to model the balloon's elevation h as a function of time. So if we want to figure this out, h stands for our height and t is time. We know that we are rising. We have a slope of 40 feet because we are going up 40 over 1 each time. And we have an initial value at 20. So our y-intercept is at 20. Oops, so this should be a t, sorry, not an x. Alright. So we want to know what the domain of this function is. Remember, domain is looking at our x values. So if we look at our domain, we have that it can be anywhere from 0 minutes up to however long. So x is greater than 0. And our range has a lowest of 20, and it keeps rising according to our graph. So our range is that y is greater than or equal to 20. And then no, this is not, they're not different. So when will the balloon be at 500 feet above sea level? So we want to use the function we have. So 500 feet, that's our y value, or our height. So we want to plug that 500 in for our y value, which equals 40. We still don't know the time, that's what we're trying to solve. So now to solve this, we want to subtract 20 to both sides. So for 480 equals 40t. So if we divide both sides by 40, the total time it will take will be 12 minutes for this balloon to reach 500 feet. Let's flip over the page. We have a candle, and it's 10 inches tall after burning an hour. After burning 3 hours, it is 9 inches tall. We want to write a linear equation to model the height of y of the candle after burning x hours. So let's start by creating a graph. So we're looking at hours for our x and inches for our y. We know after 1 hour, it's 10 inches tall. After 3 hours, it's 9 inches tall. So let's first find our point. So we're going to label this hours. So it'll be inches. So at 1 hour, we have 10 inches tall. In 3 hours, it's 9. So to create our equation, let's first find our slope. So we want to take our x2 minus our y1 minus our y2 over 3 minus 1. So 9 minus 10 is a negative 1. 3 minus 1 is 2. So we have a slope of negative 1/2. So if we plug that into point slope form, we know we have a slope of negative 1/2. Let's use our first point, minus 1 plus 10. So now let's transform this into our point slope, or slope-intercept form, which we've worked on the last couple of days. So negative 1/2 x, negative 1/2 times the negative 1, say positive 1/2 plus 10. So if we combine our like terms, negative 1/2 x plus 10.5. So how much of the candle burns each hour? Well, based on our slope of negative 1/2, it says that every hour it burns 1/2 inch. So how tall was the candle to begin with? Well, if we look at our original equation, the candle would be 10.5 inches tall when we first started. Alright, let's look at one more example. A cab driver charges an initial fee regardless of the length of the trip, and an additional amount for every mile driven. For a 3-mile trip, it will cost you $4.25. For a 6-mile trip, it will cost you $6.50. Find a linear equation that models the cost. So let's start with creating our table. So x will be our miles, y will be the cost. So it's saying for a 3-mile trip, we're paying $4.25. For a 6-mile trip, we're paying $6.50. So if we want to write our equation, let's find our slope. So if we do $6.50 minus $4.25 over 6 minus 3, $6.50 minus $4.25 is $2.25 divided by 3. So we have a slope of 0.75. So if we write a function, c of d, so the cost of the distance, equals our slope times by x minus 3 plus $4.25. So now we can distribute. So we end up with 75 cents times x, and then we have 0.75 times by a negative 3, which is a negative 2.25, plus $4.25. So when we combine our like terms, sorry, these all should be d. Should be 75 cents times d plus 2. So what this is saying is for every mile we drive, we're charging 75 cents, and we always add $2